Well, good afternoon, everyone. Thank you for coming to the third in our webinar series, but it's kind of the last because we're going to be talking about Anchor Standard 7 today. Just as a reminder, all of these webinar recordings are going up on MCTM's YouTube channel. There's already two webinars up on there, and they're all in a playlist that's titled Anchor Standards for the 2022 Math Standards. I'm really happy today that who we have with us is Terry Wyberg from the University of Minnesota. Terry and I go way back in the day, maybe 30 plus years ago. We both worked in Minneapolis and taught there. And then we've both gone on to do other things in the Minnesota math community and beyond. So Terry did a training on Anchor Standard 7 for 3 days in June, and he's going to give us just an hour or less snippet as to what are some of the changes we can expect in Anchor 7 Standard 7 for the new standards, but also just some ideas of what that might look like in Minnesota K-12 classrooms. So at this point, I'm going to turn it over to Terry and let him talk. I can see the chat, so if you have questions, feel free to throw things in the chat, and I'll stick around for a few minutes afterwards for some questions.
Okay, so we are going to start talking about Anchor Standard 7. And so I'm putting my screen up and I'm just doing my iPad so that I can write on things. So there's Anchor Standard 7. So, or at least that's the title page of my notes. And this morning, I took and walked my 3 golden retrievers, or 2 of mine are mine, and then one of them is we just are dog watching. But it was such a gorgeous day. So I want to make sure that the people in the webinar that are online right now in Zoom, they can put something in the chat room. Would you please put like 1 to 10 on how good of a day it is outside today in Minnesota? So the weather people said it was a top 10 weather day, but I'm just curious on what you think the days are. And then people put reasons. So I'm seeing 9s and 10s and 6.5. I don't know. Sarah, does it pick up their answers in the video?
No, it doesn't. So just reading them out is always a good thing.
So if you're watching this a year from, or maybe 6 months from now, and it's, January and you're going, oh, it's a 1, you can put a 1. But today it is a top 10 weather day. It was absolutely perfect. And the dogs loved it. But really, instead of talking about the weather, we're going to talk about Anchor Standard 7. And the focus that today, what I want to make sure that we look at is, first of all, just look at what does it mean to look at patterns? Because when we kind of developed this Anchor Standard, we just said patterns run everything. Sarah, what would you say the definition of math is?
Math, of course, is a study of patterns, and mathematicians notice, describe, and generalize patterns.
So even though Anchor Standard 7 is maybe the last numerically, it's probably the most important. I think Anchor Standard 7 kind of just spreads through all the other Anchor Standards. But I think it's, for me, I think like everything that I do almost every day as a math teacher is around Anchor Standard 7. So that's what I'm going to try to convince you of today. And then our second focus, after we look at patterns, we're going to look at representations and just look at how representations just give us a unique perspective on different things. And then what we're going to do is we're just going to wrap it up and really talk about what does it mean to be an anchor standard. And what the anchor standard really means progressions. And so we're just going to look at activities and how teachers are supported to teach Anchor Standard 7 or according to Anchor Standard 7 with existing curriculum, existing books and stuff, that's resources that are out there. So very excited to talk about Anchor Standard 7. And then these are all the benchmarks. So there's a ton of them. And Sarah, why did you put hexagons? Why did you make them hexagons?
Well, number one, I love hexagons, but it was actually started in social studies department here at MDE. And then ELA put all their benchmarks on hexagons, and then I started getting requests for math to put them in hexagons. So Mindy Strom, who's a Compass math lead, has put all of them in hexagons, and they're linked in the one-stop shop of math links. And I'll put that in the chat, but I'll also put it in the description to this video.
Cool. Cool. So we're going to start out here just to some, I just described what we were going to do, but we're going to start out with a number talk. So this is really not Anchor Standard 7. This is really Anchor Standard 5 or 6, depending on your mood. But what I'd like you to do in the chat, and then if you're watching this in January, what we're going to do is realize that this is a 10 by 10 square. And we want to count the gray squares around the border. And I'm just curious if you could write an expression that would count the number of gray squares that go around the border. So in the chat room, so if you're attending this now on Zoom, in the chat, would you put an expression that might count this?
And if you're
And
watching the
just doing it
recording,
around the border.
yep. And if you're watching the recording, just pause and do some thinking, and hopefully you have someone around you, your child, a colleague, and talk to them about it.
This is really cool. And so I'm just seeing some names and just curious on what you were thinking about. But David, if you don't mind, if you wrote 2 times 10 plus 2 times, wait a minute. I'm sorry. Yeah, plus 2 times 9. David, do you mind telling us what you did to figure out 2 times 10 plus 2 times 9?
I did the top row and the bottom row. Those each have 10. And then,
So this has 10 and this has 10?
yeah, and actually, it should be 2 times 8. So that was a mistake on my part.
Okay, so the 2 times 10 is the top and the bottom row, and then the 2 times you said 8, or
Yeah,
change that to 8.
I might have wrote 9 when I was in a hurry and not thinking too clear.
The pressure was on with this,
So,
but it's
yeah.
8.
Yeah,
Okay, and then I'm seeing the 2 times 8, and then that is the left and the right columns.
correct.
Okay, so now what I'm going to ask you to do is just to imagine if we kind of look at this. I didn't know how this would work out with the webinar, so I wrote a whole bunch of different ways to do it. And David, I predicted your way. So when I plan for my number talks, I plan and I predict different ways that people might do it. And it's really about connecting like the image with these symbols that represent different things. One of the things that I really like, David, what you said is you kind of connected it and you said, this is what this part of the expression means. This is what this part of the expression means. Now, what I'd like you to do is if David wrote 2 times 10, so I'm sorry, he had a 10 and a 10, and then he had an 8 and an 8, and he wrote 2 times 10 plus 2 times 8. What I'd like you to do in the chat room right now is to write down what David would write if he was doing an 8 by 8 square. But it's just about David, not what you would do, but what would David write if it was an 8 by 8 square. And so again, if it's January for you, just hit pause. Liz, thanks for putting something in there. Charlotte, it's good to see you do that. Okay, and there's a ton of math that we could do today. And so what I'd like you to do is just to realize we're just kind of going fast. And maybe we won't get to being able to do everything before we talk about it. So maybe I spoiled it right now. But again, if it's January, you want to hit pause, you can and think about it. But I really wanted to tease out the difference between Anchor Standard 5 and Anchor Standard 7. And really the difference is that I see is in Anchor Standard 5, you're just looking for composing and decomposing numbers. And you can do it in a bunch of different ways. And these objects just help you do it. With Anchor Standard 7, it's really looking at how things change and how things stay the same. And so when we initially wrote Anchor Standard 7 and we were looking at developing pattern and order, one of the first things I ever thought of was trying to develop pattern talks. And so we kind of did a pattern talk and we kind of just did a Anchor Standard 5 versus Anchor Standard 7 kind of way. But if I had one thing that you could do K to 12 is to do pattern talks well. And so right now, and I put some benchmarks up that support what we were just doing. But this is what a pattern talk might look like, but we really didn't do it from scratch. And so I'm kind of skipping around right now. So right now, when I do a pattern talk, first of all, I steal almost all of my pattern talks from Pattern Talks, visualpatterns.org, and I have a link in the slides coming up later on. But this one I made myself. And why I wanted to make it myself is because I wanted to juice it up just a little bit, kind of a middle school, high school pattern talk. And I drew latte cups because every morning I like to have a latte. And if you look really, really closely, you can see the latte art within those. They're little hearts. But what I'd like you to do is if you are sitting around January, these are hot lattes. If you are sitting around today on the webinar, these are ice lattes. And I just want you to imagine and think about what's changing and what's staying the same. So if you wouldn't mind in the chat, just write same, this is what I see, change, this is what I see. And you can just go ahead and enter it at any time. And if it's January for you, just hit pause. And if you want to write different, you could write something different or how it's changing. Cool. And people are noticing all sorts of really cool things. And we could discuss. I see people are writing there's one on the right-hand side and the bottom that's staying the same. There's always a little bit more on the left column, and there's a little bit less in the next column over. I'm seeing all sorts of cool things, but when I'm doing a pattern talk, I would have a discussion about this, and then I would pass out a piece of paper and ask kids to sketch. What do you think figure 4 would look like? So go ahead and pause and draw a sketch. What do you think figure 4 is going to look like? And if you're in the chat room, you really can't draw in the figure, but well, I guess you can. That Zoom has cool things that you can do now to put in pictures, but just imagine drawing it. And then that would be figure 4. And then just for time's sake, these are some things that I usually get when I do a pattern talk, when I have kids draw this on their pieces of paper. Some kids draw dots. So you'll see this, there's just dots. Some kids want to do the latte and they put the art in there. And then some kids kind of connect symbols with the lattes. So they'll write symbols along with it. And then some people say, I don't want to draw those lattes. I don't want to draw those dots. And what they'll do is kind of start to get at an expression. So what like David had for an expression, they would have this as kind of an expression. And once we get to that, once I get figure one, figure two, figure three, figure four, um, I want to step back here. I have some in my notes. I find with my notes, what I do is I just gray out some things so I don't forget. Uh, I just want to talk a little bit about patterns and pattern talks. And sometimes when kids draw figure four, they have different reasons than and might have a different picture. And I want you to realize that if they have a different picture, they might have good reasons for why it's correct. And it could be a correct pattern. But when kids are figuring out a pattern talk, they're trying to figure out whoever created this, what they might write for figure four. So it's really my pattern, not anybody else's pattern. And I'm not trying to be a huge ownership kind of a person, but I want kids to realize that if they try something, they're not necessarily wrong. They're right for their thinking, but they're trying to match what I'm thinking, and it's all good. Like it's all good. But once we figure it out and we kind of agree on figure four, then I'd want them to figure out what does figure 10 look like. And again, you want to pause, try to draw a picture of it. You might select a picture that looks more like the far right one rather than maybe drawing all the dots. And then, since this is a webinar, we're going to go fast. These are some drawings that I usually get. And again, they're connecting what they see in the image. They're noticing what's changing, what's staying the same. And they're writing an expression kind of to match what is in figure 10. And just so you know, I think I'm pretty happy stopping at figure 10. It doesn't always have to go to figure N, depending on what your grade level is. But what I'm trying to get kids to do is to notice, again, what's changing, what's staying the same, connections between the image and the expression, and then how to chunk things. And then again, I might ask, what would people write if people saw this? How would they chunk this? Again, the time that we're having, we only have 15 minutes. We're going to just stop. But if I was drawing expressions for maybe the one way that people saw 9 times 10 plus 11 plus 10, then these expressions, like these expressions might just capture what figure 1, figure 2, figure 3, and figure 4 look like. I'm going to just keep going. I do want to stop here for a little bit. When David was talking about the border problem, all of these expressions all have meaning to it. And so if you're helping students make connections between the expression and the figure, and then the chunks, then what can happen is you start naming what each of those pieces mean. And I want to continue making those connections. Now, that was just a quick pattern talk. Kind of weird to do it quick and do it on a webinar, but here are some pro tips, as Sarah would call it. So tips that I've been focusing in on and making my pattern talks really are a lot better. So over here is kind of what I've been emphasizing. When I do a pattern talk, I try to write the expression down and not write how many latte cups there are. Because if kids see how many latte cups there are, they really think about the difference between the two. And it's hard to pick out the 4 and the 6 and the 8, although they're there. I find it that kids get better at looking for pieces and be able to make connections and see patterns and what's changing and what's staying the same if they look down across this column and look at those expressions. You can see some regularity and you can see some change. Over here, you see change and not really emphasizing the differences. And again, I just wanted, this is, first of all, my pattern talks have gotten so much better when I focus in on structure. Also, when there's nudging that you can do. So another pro tip that you can use when you're doing pattern talks is to kind of nudge just the chunks, like what you see in chunks. So if a kid draws all the different lattes, my comment is usually, oh, that looks interesting. And then if I want to nudge a little bit, I can start nudging. Well, maybe we don't have to draw all those different circles and dots, or try to catch somebody doing it and then feature that in our discussions. The next thing is if you go to visualpatterns.org, they write all their patterns and their figure numbers from left to right rather than up and down. And I have found that kids, and maybe you, see regularness up and down rather than left to right. And so I've been trying to change all my pattern talks because I've done them for, 10, 15 years from left to right, and I'm doing them up and down. And so I don't know. In the chat, why don't you say which way do you see change and where do you see sameness if you were thinking about this? So write it in the chat. Do you like it left to right, the pattern talk left to right or up and down? I should have put a poll, but just in the chat. And I'm seeing a little bit different, but if I'm counting,
Yeah, definitely more up and down with a few left to right scattered in.
yeah. And there's not one right way to do it. I'm just finding it's based on conversations that I'm having with students when I'm writing those connections with expressions to the figures and then seeing how the expressions change and then stay the same. I'm finding my discussions are better when I'm writing up and down than left to right. And I still do them left to right every once in a while, and I still do them up and down probably more. And Liz, yeah, Liz made a comment left to right because that's how I've typically seen it. Cool. But you're not wrong for doing it either way. I'm just saying I have better discussions when I'm up and down.
I think it just builds flexibility, like you said, to do it both ways with students over the course of a year, giving them experiences with both. And I wonder if up and down you have better discussions because it feels a little bit more like we tend to make most of our tables vertical versus our tables horizontal. But
Yeah. Yep. And so I think a little bit of both, but I'm finding I'm having better discussions up and down. Just to recap, when you're doing the pattern talk routine, I go, what do you notice that's changing? What's staying the same? When kids are talking, I just listen and I don't move and I don't gesture and I don't revoice until after they've finished talking. And then I'll revoice and gesture. And I try not to write on the screen right now because people see different things. So I try not to write anything when I'm talking about what's staying the same and what's different. But when kids are talking, you are not writing and you're not gesturing, you're just listening. And then when I revoice and gesture, I'll do it after I've had a chance to kind of digest what they said. When they sketch the next figure, I want to make sure that they know that when they sketch figure 4 or whatever it happens to be, there's lots of right answers. There's infinitely many correct responses to figure 4. There are, except for it's my pattern. And so I want to make sure that they realize that they're not wrong for picking a figure 4 that doesn't match mine. But then when it matches mine, we're celebrating. And then I want to be able to listen and then sketch. And then when we write figure 10 and write an expression, that's where I'm focusing on writing for structure and trying to get an expression that kind of changes the same way for each of those figures. And then sometimes I go to figure N, but you don't always have to. I think a mistake that I made early on with these is to try to get that formula done. But really, it's about what's changing, what's staying the same. That's the most important. I find that going backwards is always a huge thing. So after they've kind of come up with figure 10 and some structure to kind of describe figures 1, 2, and 3, then I might go after figure 0 because the expression, it gets really interesting and the expression supports them what figure 0 could look like because it's not always 0. There's not always 0 lattes.
Terry, before you move on, can I ask a clarifying question?
Sure.
Can you go back to your list of 5 things? And number 2, you said make sure they know it's your pattern.
Yeah.
But by your pattern, that might be a student's pattern that you've selected, correct? Like you selected David's pattern for us to do the next one, but you want them to do the one the class has joined in. It doesn't necessarily have to be the teacher, correct?
Well, there's two ways that we're talking about a pattern here. So one way is the pattern itself, the latte cups. Figure 4 is if I selected these three figures, these latte cup arrangements. Then the fourth pattern is whoever selected it. Then there's expressions to kind of talk about how they change and how they stay the same. These expressions can be different. So just like with the number talks, and if we go back up here to the number talk, woo, um, there's four different patterns that you can, or expressions that you could write. So if a student comes up with 4 times 10 minus 4, which a lot of people in the chat room did, when they generalized their pattern, maybe they would use that format. So there are infinitely many expressions that they could go along with the pattern. And so if a student picks an expression, that's not necessarily the pattern, that's just how they describe the pattern. So
But thank you for
I
clarifying.
guess maybe I didn't make, but so what I wanted to say was these expressions right here could be different, and a good pattern talk has different expressions, and so these could be different. This is what I mean when I say my pattern is what does my figure four look like? But what do you write for expressions? Then that's the student and how they see change and how they see differences. So really good question.
Thank you.
So that's what mine means. What is this one going to look like? And then what they have, like what they write for expressions, that's where you want to celebrate the differences among your classroom and your students in your classroom. But really, all of this is really, if you focus in on Anchor Standard 7, it's just patterns and relationships. And so Mark Driscoll wrote this book called Algebraic Habits of Mind. And he said there's probably more than 3 algebraic habits of mind. And algebraic habits of mind are what really good people that are really good at algebra do. What do they do when they're working on algebra stuff? And so they're kind of just ways that people think that are really good at algebra. And we want all our kids to be really good at algebra, not necessarily good at pattern talks, but good at algebra. Like the overarching thing that I want kids to be able to do is in arithmetic, we're kind of doing, and then algebra is kind of undoing. So an algebraic habit of mind is getting kids to notice what are you doing and then what are you undoing. The second one, and I think that's what, like if we really talk about math practice 7, is abstracting from computation. Now, math practice 7 is different than Anchor Standard 7, but abstracting from computation is just noticing what's changing and what's staying the same. So if I was going to write down like what's the meaning of this, abstracting from computation, it's noticing what's changing and what's staying the same. So when we're doing this with kids, you're constantly looking for when kids are noticing what's changing and what's staying the same. And in fact, we can really force that. We can force that by just asking them the question, what's changing and what's staying the same. And that's why I love pattern talks, because you can focus in on that question. And when you focus in on that question and you focus kids' thinking on that idea, they're developing algebraic habits of mind. And then building rules to represent functions, we're kind of just helping them along with that. That's really what a pattern talk routine is about, is they're noticing what's changing, what's staying the same. They're making connections between a figure and an expression. And eventually they're just building a rule to represent functions. And so what I want you to realize is when Anchor Standard 7 was written, it was really about developing algebraic habits of mind. And you really see that with looking at relationships between a figure number and then the latte cups, the number of latte cups. Now, I mentioned this before, but one of the best websites that I have for generating these are the visual patterns. And I've stolen, like all of these. You can see the border problem. Actually, I didn't steal that one from this website, but I stole it from somebody else. But this visual patterns is one of the best places that you can just get a variety of visual patterns. And it's one of the best things you can possibly do. I just wanted to put some in here. I drew this one. This is also partly stolen from visual patterns, but again, I wrote it up and down. and I drew little flowers. But I really liked it because the fives pop. So if I was working with kids and they're working with fives, I can just see the fives. But instead of just having exact fives, there's a little overlap. It just spices things up when you have a little overlap. When I first started to do pattern talks, maybe 18 years ago, I love this toothpick one, and I stole this uh, um, from and I think not the NAPE. I stole it from PISA. So PISA is a international test, and I really liked it. But what's cool about this one is it builds on top of it. So instead of a focus in on five on this one, I really focused on how you're taking something and you're adding to it, adding to it, adding to it. But that's different than this one because you don't build, like if you look at figure one to figure two, you'll notice that this tends to be a harder one for kids because you don't build figure two based on figure one. You have to build it again, but you're noticing what's changing, what's staying the same within that, but you're not building it right on top of it. So as you're picking out number talks or pattern talks, you can kind of pick like, what are you trying to go for? And this one tends to be easier for kids because they can see those threes just stacking on top of each other. This one, it's harder. And so it's a little bit more challenging one, but kids can do hard things. So it's a really cool one. I love this one. Adults have a hard time with this one, but to me, I just get excited about doing this and giving this to kids. And it turns out that this one's proportional. Like there's seven of them. There is seven and seven more, and there's seven and seven more and seven more. I mean, you can start to see that this is proportional, which is really cool. But again, it builds on top of each other, but in a really complicated way. I like this pattern talk because the kids start to see where the two pops in figure two, where the three pops in figure three. This one, if I'm getting into quadratics, I like this because of the squaring idea. Figure one's really hard, so a lot of kids start with figure two and figure three and then backtrack to figure one. So it's kind of like figuring out what figure zero is. This one I stole from Joe Bowler. It's also on the website, but I love this one. And she went to figure zero and then figure -1. And it's really cool. I made this one up and I just wanted to show how we were working on the area formula for a triangle. And so I developed this one. So this was my own. I didn't steal it from anybody, but I wanted for kids to notice when you're figuring out area. So the dependent variable here is figuring out area, and the independent variable is how that base is changing. And then just getting them to figure out, what's changing, what's staying the same with that. And then like as you start to build this, you can start developing an idea of how area changes. This is one of my favorite ones to do, and I'm noticing the time when we have a ton to do, so I'm not going to do this full one, but you can change up your routine. And as you've done a bunch of pattern talks, you can go, okay, well, here's figure one. What do you think figure two is going to look like? Now, there's infinitely many figure twos, but you're going to get a wide range of variety when you only have one figure and you're trying to figure out what does figure two look like. So again, pause right now, try to draw. What do you think figure two might look with dots? And again, if you're on the webinar thing, you can do whatever you want, but we're going to whip and show you that this is what figure two looks like. When I do this and ask for, what do you think figure three might look like? I get a ton of different ways, and some of them are better than my figure. So sometimes I've gone and said, let's just do this one. It looks a lot better. But what do you think figure three looks like? And I really want to make sure that people realize that there's so many different infinitely possible ways, and it's okay for them, whatever they're trying to do. And what I get an idea is get them to focus in on what's changing, what's staying the same, and then giving a reason for what they decided what figure three might look like. Well, here's figure three. And then now, once kids have seen three, almost always they get figure four exactly how I predicted it, like how I imagined what figure four would look like. And so this is really just a change in the routine, and it helps kids be flexible. And again, there are infinitely many figure fours, but there's only one that I have in mind. There's just something about pattern noticing that three sign kind of really captures it. If you have three figures, getting that fourth figure, kids just start to see things. And it's going to come back later on in this talk, even though we have 25 minutes left. But I also want you to realize there's just some goofy things that happen. And I spent 4 hours with this, and I were really in the chat room and just try to guess, what do you think is the next number? So if it goes 854917632, what do you think comes next? Or maybe that's not the right question. Maybe the right question is, why do you think these numbers are in this order? So hit pause if you are in January and you're looking at the webinar. And I'm just going to maybe just give you a hint if you are here. It is my phone number. Does anyone have an idea of when you spell things out, why 854917632 would be in this order? Sarah, thank you. It's alphabetical. And so it was really, I spent like 3 hours trying to figure out this pattern, and I figured out a pattern, but someone in my class said it's alphabetical, and it kind of took away from me. All right, so now I have a graph, and I think one of the best questions that you can constantly ask about relationships between variables, and typically we put our independent variable down here and our dependent variable right here, and I'm just trying to figure out, what do you notice here? Becky, 0 would be next. So sorry, in the webinar, someone said 0 would be next. Yes, 0 would be next. And then 10 would kind of come in the middle somewhere. 10 would come in right here. So it's kind of a cool pattern. So thank you, Becky. I want you to just think for a minute about what you notice with this independent and dependent. And just what do you notice about this graph? I'm going to erase that. So in the chat, if you would just write something down that and nobody in the chat right now is writing anything down of any patterns they notice. So it's kind of goofy though, because there's no context. And so it kind of stinks. So Amy says it's really random. And I kind of agree that it's really random. It turns out that in in this column right here, where it says 3323539, those are the number of benchmarks at each grade level. So these are grade level and then benchmarks. So now that we had context where this is grade, and then these are number of benchmarks of Anchor Standard 7, what's something that you notice about or have a comment about? I know Sarah suggested, why is there only one for 6th grade? And I am not sure. 3 seems to be a trend. It seems like maybe 3 should go across. 8th grade has a ton. Cool. And David's noticing some things. I think we were trying to stay about the same, but it turns out 9th and 10th has a whole bunch more. I didn't even graph them. Kindergarten has 2. So if we wanted to put a little dot at 2, that's kind of like the mode of benchmarks, but 8th grade has a lot. 6th grade only has 1. So that was just a fun graph. And now what we're going to do is focus in on representations. And I'm looking at 20 minutes. So I had a problem that I wanted to work on. It was this tennis ball one, and using a activity from Desmos. And so I'm going to encourage you to go for it because it has this context of a tennis ball. And then it tries to get kids to describe what does it make to make a good tennis ball. And then it has interactive graphs. And so they graph the relationship between bounce and the height that it would at each bounce. And what it does is it gives graphs meaning, and graphs tell stories. And all of these representations tell a different story about the same relationship between variables. And so with Anchor Standard 7, like if I really wanted to kind of look at Anchor Standard 7, there's always an independent variable and a dependent, or several dependent variables, or several independent variables and one dependent variable. But you're connecting them, and representations are one way that you can make really allow things to tell different stories. So I'm not going to do that in this webinar because that would take the rest of our 20 minutes together. But there's some really cool things. I'm not going to do the number talk, but I am going to do the progressions. So we're going to spend the last 19 minutes together talking about progressions. And so when I was looking at Peter Liljedahl's new book, it's a green book, and it has tasks for grade K to 6. And almost all of them would be related to Anchor Standard 7. And, Anchor Standard 7, again, if you look at this and read it, I'm not going to read it to you. I'm looking at patterns. I'm looking at connections among representations, and then solve problems and make predictions. And so this star star moon problem, the Peter Liljedahl book has some really cool ways to introduce this task. And then what they ask students to do is to extend the pattern. So what comes next? Very, very similar to a pattern talk. And so it tells me that I can do these in first grade, I can do them second grade, I can do these what comes next, and they're kind of all in all the curriculums right now, and in all those different grades. We did this exact task though in a first grade classroom, and this extending the pattern didn't seem like it was anything new. And then they said, well, what about what comes before? And so then all of a sudden it was like the challenge level was it upped the game, but it really is developing algebraic habits of mind of what's changing, what's staying the same. To decide what comes before, you have to, or what comes after, you really have to be able to develop that algebraic habit of mind that's going to develop K to 12 all the way through. And then this was, I thought, the brilliant part is what comes in between. And so just to make sure that we have this in between, would everybody we're going to do problem 21 together. So would everybody write, it's square, circle, square, circle. What do you think is the next one that comes out? And people are writing square. Okay, and then what comes next? And people are writing circle. Oh, awesome. Okay, and remember, this is type 3. These are really challenging. Then it goes square, and then the next one, and everybody is writing circle. Okay, so I guess that was just an A-B pattern, so not that exciting, but let's do 22 together. So it goes triangle, circle, 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 triangle. Okay, so people are already saying that this is triangle. So I'm agreeing that it's triangle. Then it goes circle, circle, triangle. And then what the heck is going in here? And Jody says circle. But then we had a problem. Oh, 2 circles. So Jessica said, put in 2 circles. So we had a discussion about this and try to decide. And, it's a pattern, but I think what it was a typo. So a typo in the thing. The rest of these are pretty basic, or like pretty cool. But we had some interesting discussions about what would go in there. And this one, rather than being a typo, being a bad thing, it actually led to a really fruitful discussion about what the patterns would look like and whether we can put 2 things in one, and go from there. But I thought this was brilliant, and I saw a challenge from each of the kids. And then we're just going to pause here because my Instagram, I got this one yesterday. So this is just a you know, like this whole idea about patterns, about what comes next. And when they wrote this and they said the answer is not six, I looked at this number line and I was thinking, well, what else could it be? So what you're looking for right now is what goes in this question mark. Shoot, Tanya, how did you know that? Tanya put reverse, R for reverse.
Because I grew up driving a stick shift.
So, and if you wouldn't have that experience because you're a legend, you know, like I spent 15 minutes trying to figure this out and I finally had to look up the answer. And then I realized that I have a Jeep and it has a manual transmission, but that is reverse. But I spent like 15 minutes trying to figure out what's the pattern. And there is a pattern, even though it kind of tricks us and it says it is reverse. So sorry to put that in there, but kids, when kids have experiences and they say something for a reason and it's worth listening to. And so even we can learn things from each other. The last thing we're going to work on we're going to work on two more things. And I have about 18 different things that we spent 3 days working on in July or still June. It was still June. And one of the things that really helped me the most is something called choral counts. And so we're going to choral count together. But if you look at the standards right here, they were written, I'm sorry, benchmarks. If you look at this one, I'm getting some feedback there. Does someone have, oh, Tanya, you want to turn your microphone on? Thank you. These skip counting ideas. And when you look at kindergarten, they're skip counting by tens. And then in second grade, they're skip counting by twos and fives and by tens. And then again, it's 2 by 5s. And so this whole idea of skip counting was a really cool thing in the standards, and it's in Anchor Standard 7. And so then this book of choral counts came out, and it transformed my teaching for everything. And so it really helped. And one of the things they do is they said kids experience joy when they count together. So if you look down at the cover of the book, they're counting just objects. So that's the counting collections. But the choral counting is a little bit different. And what I'm finding is choral counts really exemplify Anchor Standard 7. And you can do this at every grade level. And I had to practice, and I'm getting better and better and better and better at it. So when I do a choral count, one thing I had to learn is I had to give kids a runway. And so what we're going to do, Sarah, if you don't mind, we're going to choral count together.
I'm ready.
Okay, so just another tip is on Zoom, there's a slight delay and it makes choral counts terrible. I mean, it really changes everything. But if I have one person doing the choral count, and usually I'd have the whole class choral count, then it makes it a lot better when you're doing Zoom, just one person. But when in your classroom, you're doing everybody. So Sarah, you're going to be the only one that choral counts. So go ahead. Would you just choral count with me? So we'll start here. Okay.
3, 6, 9, 12,
12.
15.
Okay. And then I'm not going to count because I can't keep track of it. So just imagine all of us are counting together and I just can't write and do a choral count at the same time. Okay. Keep
You want
going.
me to keep going? Okay.
Yeah.
So 15, 18, 21, 24, 27, 30, 33, 36, 39, 42, 45, 48, 51.
Okay, and we'll stop there. And again, this whole idea of threeness. When I'm doing a pattern talk, I have 3 things typically, and then build on it. With this one, I usually give a runway of 3 things and then keep writing. And then typically go 3.5 rows, because if kids are going to look across and then up and down, then all of a sudden I get different ways that kids and different patterns that kids see. So now I would just have a discussion about, what do you notice that's changing, what's staying the same, what do you notice? And I can get all sorts of things that kids notice with this. And again, since it's a webinar, I'm not going to go that fast, but typically kids notice that this goes up by 15. And then someone else will go, well, wait a minute, that's every column goes up by 15. And they'll say every single one of these columns, they increase by 15. And that's really interesting. Does anybody, just really quick, I'm going to give you time to just think about this for a minute. Does anybody see anything else that they think is really interesting in the chat? And so I'm just giving you time to think. So Amy wrote down that, and Felicia also wrote down that the ones column is going 3, 8, 3, 8. And then in this column, it goes 6, 1, 6, 1. And this goes 9, 4, 9. And so what do you predict? What would go in the next one after 51? If that pattern still goes, the ones digit is going to be a 4. So let's see. Yep, 54. Ooh, that's so cool. And then it goes 2, 7, 2, 7, 5, 0, 5, 0. And so what math is about action and reflection, action and reflection. And so in pattern talks, we typically ask kids, what do you notice? What do you notice? That's reflection first, and then we start acting on it. In choral counts, we're saying, let's do some action. And then when we ask, what patterns do you notice? We're looking for reflection. So math is action, reflection, and it's really emphasizing and pulling out algebraic habits of mind. We might ask, which row would 93 be in? Which row, which column would 93 be in, and in which row? So there's lots of different questions that you can ask. I made sure I wrote one in there just so you could see. But then I said you could do this grades K to 12. And one of the things that happen are fractions, like when we look at fractions. And so we gave a context that this paper strip represents one whole sandwich. And then what we did is we cut up the sandwiches so you would only get 3/4 of a sandwich. And so this right here would be 3/4. And if we did a choral count with this, it'd be 3/4. And then again, I want to write that runway, but 6/4. So another 3/4. And another 3/4 would be 9/4. And another 3/4 would be 12/4. And then another 3/4 would be 15/4. And we found that when we have those paper strips, that kids connected a whole bunch of different things, especially with fractions. And then we're able to write out these. And I want you to think for a minute. What do you notice about skip counting by 3/4? What are some things? And I'm just going to write some more in here. And I could just keep going. So really quick in the chat room, and I'm looking 6 minutes left. Would you just write something that you notice? Amy wrote every 4 3/4 is a whole, is 2 wholes. So this is what it would look like if we were choral counting with fractions. And these are some things that kids notice. What I have found that I'm a better teacher of fractions because I'm choral counting with fractions. how this supports Anchor Standard 5 is how fractions work. The numerator names the number of pieces, and the denominator names the size of each piece. And one of the mistakes I made when I was teaching fractions for 35 years is I really didn't start going over one too much. I didn't iterate enough. And with a choral count with fractions, you're iterating and not just partitioning. So you're leveraging, kind of a relationship between independent and dependent variables just by putting those down. Kids will notice that 12 fourths is 3 whole sandwiches. And if you just look right here, you can see those whole sandwiches just popping up as you rearrange pieces. I get a chance to talk because most kids, when I look at these from 15 fourths to 30 fourths, most kids will say it goes up by 15. And I get a chance to talk about it, that we're really not adding 15, we're adding 15 fourths. And I have found my kids are so much better at fractions because of choral counting. And really, it's because they're using algebra to learn arithmetic. And I think for me, this is a huge thing. And then just my tips is 3 is the magic number to see patterns and connect context and visuals. If you didn't use visuals and you just wanted to do this, you could just write it just without any of the pictures or with any of those paper strips. When I ask kids, to look, then you start making comparisons between what do you notice that's changing this or staying the same with just whole numbers with fractions. And one of the mistakes again that I've made with teaching fractions is thinking that they're new numbers, and you really can't use whole number thinking. And with choral counts, it's really helped me realize that when you choral count, that you can start seeing relationships between numerators and denominators, but you're also leveraging your whole number thinking, which brings up your confidence. And then this is a different choral count, but I did this I started at a half and then went up by 3/4. So in the benchmarks in Anchor Standard 7, you start at different numbers, and we should progress through that, not just whole numbers, but with fractions. I don't know if you see some connections between those, but this is starting at 2/4 and counting by 3/4. And in the right hand choral count, what I did is simplified the fractions or made them mixed numbers. Every time I do a choral count with fractions and then with the mixed numbers and stuff, someone will say I stopped thinking. Like I can get the next answer, but I stopped thinking, and they think it's like wrong. And it turns out that it's really a good thing. It shows that you're noticing patterns and you're showing relationships. I'm going to keep going. I'm noticing that we have 2 minutes left. And so I wanted you to know that I'm starting to see Anchor Standard 7 in curriculums. This right here is a second grade activity. And the second grade activity just said how many, there's snow people. And the kids all made snow people with 3 circles. And then they were asked to figure out, they said, how many circles would we have to cut out if we had before they did this, they said, write expressions that count the number of circles for each snow people. So this is what we were doing when we were doing a pattern talk previously. And why I wanted to show this is there's different ways that kids are thinking about these in second grade, and they're encouraged to think about it in second grade about how they might write the number of snow people. And then they're asked to figure out how many circles would be needed if we had to write 15 different snow people. And what I'm really excited about is it is really just a pattern talk, and it's in all these different grades. But a pattern talk is really relationships between independent and dependent variable. And you can do it in second grade, third grade, fourth grade, all the way through 12th grade. I'm looking at my time, and I have about an hour's worth more of stuff to do, but I think we're going to just stop right here. And what I wanted to get from you is for you to, first of all, when you see Anchor Standard 7, just think pattern talk as one way just to begin with it, and then start thinking algebraic habits of mind that it develops. And that's doing and undoing, abstracting from computation, building rules to represent functions. And then it really permeates all the different grades, K to 12, in so many different ways. I focused on the lower grades, and I have some upper grades as we come up. And one of my favorite ones is the hamburger problem. This is a 100 burger from the, um, and we start getting into linear functions, which gets us to eighth grade. And then these are the equations that my students have come up with. There's a dripping water problem that's really kind of cool and talks about seventh grade, sixth grade, seventh grade. So we were just going to go through the different grades and have different problems. This one tends to be a linear, tends to look linear. So Apple's pricing scale is more of a linear model. This right here, this BOGO problem, if you buy one, get one 50% off, turns out to be a quadratic model. And then I was going to finish with a problem that we can do in high school and even in middle school, that I didn't get till I was in graduate school and never figured out to get at graduate school. So I'm going to stop right here, and we're right at 2:01. So Sarah, do you want to add anything?
No, I just want to say thank you to Terry. There is so much in here, and I was wondering if anybody that was at the June training, if anybody wanted to highlight something you heard in June or maybe heard today that has just stuck with you for Anchor Standard 7. Anybody willing to come off mute and share anything? They might not, but I saw several names of people that were at both. So cool. Well, thank you everybody for coming. This webinar will go up. I'll include, if Terry hasn't put it in the folder yet, I will make sure that I get his slide deck in there so you can go back and look at some of those problems that he went past. Terry and I are the same bird. A lot of you know that I always have way too many slides in my presentations as well. And I love the hamburger problem that he mentioned at the end. It's one of the favorite ones I've used in my personal classroom. And there's a bunch of other really amazing things in there as well.